Hey, how's it going? Wait, wrong window. Awkward. I'm not starting the video over though. Okay. I conjecture. Where's my mouse? Oh, there we go. I conjecture that any 10 raised to the I can be represented as 1 plus 9 times some number n. So yeah, let's see if it works for the base case. So 10 to the 0th equals 1 plus 9 times 0, right? 9 times 0 is 0 plus 1. All right, let's do the induction step here. So we want to say 10 to the I plus 1 equals 10 times 1 plus 9 times n. Yeah, that sounds right. Did I do that right? Maybe it's not technically induction, but okay. So yeah, we have 10 plus 9 times n, or excuse me, 90 times n. But look, there's this little thing that you can do. 10 is 1 plus 9. So you can have 1 plus 9 plus 90n. And then you can combine like terms. So you have 1 plus 9 times 1 plus 10, which is 11. Yeah, so, oh, wait, what, 10n. Sorry, got confused there. But remember, n wasn't a specific number, it was just any number. I'm not trying to figure out exactly what it is, so we could say this is 1 plus 9m, or we could call it 9ni, or something like that. The point is, there's some 9 there, right? Sure. So, what can we do with that? Well, so we know. Okay. So, yeah. So if you're trying to figure out if some number is divisible by 9, then you can simply divide by 9 and see if there's a remainder. So this goes in 5 times, this goes in 0 times, there's a remainder of 3. That means that that is not divisible. Now, there's interesting property of divisible numbers. Any number that's divisible by 9, if you add a 9 to it, that number will also be divisible by 9. So 18 and I can't do basic addition here. 27. So in like manner, you could also, if you want to know if something is divisible by 9, you could remove 9 from it, and then you could figure it out, because it's gonna apply. If you have something that's not divisible by 9 and you add 9 to it, then you're not going to get something that's divisible by 9, and it goes the other direction too. But you don't have to subtract 1 9 at a time. For example, let's say you had the number 100. You could remove 11 9s from that and just look at that number and see if that one is divisible by 9. It's not, so that means 100 is not divisible by 9, right? Okay. Well, what does that have to do with what I showed you first? Well, what does it mean if we have a number like 453? This means 4 times 10 raised to the second plus 4 times 10 raised to the first plus 4. 5, 3. I'm sorry. 5 times 10 to the first, 3 times 10 to the 0th power. But all of these can be represented as a multiple of 9 plus 1, right? I mean, you could write it in the general case as, I don't know, 9m2, and we don't necessarily know what that is, 9m1, just that it is a non-negative integer, m0. Or you could just visually see it. This is 1 plus 99, that's 100. This is 1 plus 9, that's 10. And this is 1 plus 0, which is 1, right? Well, funny thing happens. You know how you can add a multiple of 9 and it doesn't change the divisibility, or you could subtract a multiple of 9 and it doesn't affect the divisibility? So what number did we have? We had 453, right? And that is 4 times 100 plus 5 times 10 plus 3 times 1, which could be rewritten as 4 times 1 plus 99 plus 5 times 1 plus 9 plus 3 times 1 plus 0. And then you could expand this out. You could say 4 times 1 plus 99 times 4 plus 5 times 1 plus 9 times 5 plus 3 times 1 plus 3 times 0. But if you wanted to know if this number were divisible by 9, you could subtract all of the multiples of 9. There's 1 right here, and there's 1 right here, and there's 1 right here. And you see what that leaves us with? 4 times 1 plus 5 times 1 plus 3 times 1. Well, I mean, you don't need to be very smart at math to know that. That's 4 plus 5 plus 3, right? But do you notice something? 4 plus 5 plus 3 is the same as the 3 digits that we started with. This is a little trick of divisibility by 9. It's called casting out nines. Let's look at a few examples. Let's start with an easy one, like 900. All you have to do is add the digits together and see if that is divisible by 9. 9 plus 0 is 9. That is divisible by 9, so that means this is divisible by 9. Now, if you added 1 to this, then it wouldn't be divisible by 9. Then it would be 10. And then if you added 2, it wouldn't be divisible. It'd be 11. And you could add all the way up to 9, and then you would get 18, right? Once you add 9 to a multiple of 9, well, then you have a multiple of 9 again. 18 is divisible by 9, but you can repeat the process. You can add these two together and get a 9 again. So, yeah, I think that's pretty sweet. Let's do one that's a little bit less obvious. Let's say 405. You can probably see what I'm doing. I'm trying to be smart here. So 27. I'm trying to construct a number that I know is divisible by 9. I'm sorry, I'm not being sneaky at all. So yeah, these are going to be 6, and these are going to be 12, and then add these together is 18, and then 9, and it's divisible by 9. And we should be able to verify that like this. Let's see, that's 3. No, it's not 3. It's 2, and then 65. Wow. Basic arithmetic. I'm pretty bad at it. 7 times 9 is 63, right? Yeah, so that would be 27 left over. And, well, what do you know? That's 3 times 9, right? and its remainder 0, it's divisible by 9. Of course it is, because that's what I was trying to prove. Now, if it were 1 higher, then it would be remainder 1, and also adding the digits would have been higher. But I want to show you that it works even if it's not the last digit, because that might seem a little bit tautologous, right? So if you have 2,467, then if one digit went up by 1, then the remainder should go up by 1. So let's try the process here. It starts off the same, so 2, and then that's 18, and then we have 66, and then 7. 7 gives us, what is it? It's 63. It's a 63, and then 37. And 36 is a multiple. 36 is a multiple. So minus 36, you have 1 left over, and it's remainder 1. Right? Makes sense? So I think that that's a pretty nifty tool. The divisibility by 3 rule is very similar. You just have to remember that 9 is a multiple of 3. But I think that the divisibility by 9 is easier to demonstrate. I want to explain it in such a way that somebody can understand who isn't necessarily a math person. So maybe starting with a induction step was the wrong decision. Oh well, I don't know what I'm doing. I need to go to bed. All right, talk to you later. See ya. Oh, that's the wrong button. I'm using a different screen recording software, so now I'm confused here. All right, what am I doing here?